And we're going to start out today looking at law of sines. Okay? So, I'm going to draw a triangle here.
Oh yeah, we did this.
You did do this? No, you didn't do this. You maybe have done this. Yes, pizza time. Okay, yeah, you may have seen this before in geometry, I'm guessing, right? Probably geometry, maybe not. But, so you'll notice something important about this triangle. It's not a right triangle, right? Not a right triangle. Trigonometry, right, is developed from right triangles, right? Sine, cosine, tangent, those relationships are all dependent on a triangle being a right triangle, having a 90-degree angle inside of it. But of course, there are more triangles than right triangles, right? So how can we use those trigonometric functions in those non-right triangles? Well, the answer is yes, but not in the way that we have been using in the past, right? You can't use straight up sine, can't use straight up cosine, can't use straight up tangent in those non-right triangles because sine and cosine both require that you have a hypotenuse. But what's the hypotenuse of a non-right triangle? You might think, oh, it's just the longest side. Well, not always. The relationships kind of break down. But there are some creative ways to use these things. Now, I've gone ahead and labeled this triangle here, angles A, B, and C, capital A, capital B, capital C. And I'm going to also label their opposite sides, the matching lowercase letters. So opposite angle B will be side lowercase b, opposite capital angle A will be side lowercase a, and then opposite capital C will be lowercase c, which is virtually indistinguishable from the capital C, but anyway, there it is. All right. And so the law of sines, okay, states that these angles and sides are in a relationship using sine, actually. So the way it turns out is that the ratio of the sine of angle A over side A, that ratio, okay, is the exact same ratio, it turns out, as sine of B, angle B over little b, and is in the same ratio as sine of capital C over little c. Okay. They will all be in the same ratio. Or another way to put it, right, and this is just if you just do the reciprocal, sometimes the books will write it this way, or you'll use it this way, or you can just flip it all around and say, okay, this just means the same thing too. B over sine B, C over sine C, like that. All right. And so our goal in knowing this now and using this is to be able to solve for missing pieces of non-right triangles. Non-right triangles. Okay. So let's try that here. So let's solve for the missing pieces of the triangle below. Okay, this will be our first kind of example here. And let's draw a triangle. Let's see here. These triangles are not drawn to scale, by the way. Not drawn to scale. Alright, so we'll say we have a 97-degree angle right there. We'll say we have a 43-degree angle there. Oh, and I'll label the vertices here. We'll say that's A, this is B, and C. And let's say that this is so there's our setup. Okay, there's all of our given information. Okay. So, how then are we going to use the law of sines here? Well, one thing I want to point out here, right, the way we write the law of sines is not the way you're going to be setting up your work. So, for example, the way the law of sines are set up here, it's like you have all three sides and you have all three angles, and you're just supposed to show that they're equal. And it's like, well, how's that useful here? You need all three pieces. Well, that's not how we're going to use it. Okay, you can take any piece here. So, for example, if we have angle A and side A, we can then use that to find angle B or side B, right? We can just use these two pieces, or we can use like these two pieces, right? If we need to find for missing parts, or I can block off the middle one and say that these two are equal, okay, and use that as well. We don't need to have all three things set equal to one another here. So, for example, looking at what we've got. Angle A, we've got is 43 degrees, and we also have that side A is 22, okay? Meaning then that we want to start with that. We have that kind of ratio, right? We know that sine of 43 degrees, and that's going to pair up there with the 22. So we'll just write that. And again, I don't know. For whatever reason, I like to put the sine on top and the number on the bottom. If you don't like it that way, you could write 22 over sine of 43. It's up to you. It's going to be the same thing. Okay. Now, using what we're given here, we've got angle C right here, and so we know that that's going to be in the same relationship as sine of 97 degrees over, and so since I have angle C but I don't have the opposite side C, that is what we will solve for there, over the little side C there. Okay. So again, you want to start with a known side / opposite angle. Okay, that's where that's how you kind of know where you want to start in a law of sines problem. You want to locate and identify a known side / opposite angle pair. Okay, so in this case we did angle A and side A. We knew those two things, and then we'll solve the rest of the triangle that way. All right, so now we are going to solve. Now, if you look here, right, sine of 43 degrees, sine of 97 degrees, those are not on our unit circle, right? So we can't solve those mentally, which means these problems more than likely will be calculator active problems, okay? So when we go to use our calculators here, and you might want to have those out then, right? Make sure that you press that mode button. Okay, we've been working a lot with radians, but now we're talking about degrees, so we want to make sure we change that mode to degrees. Okay, I'm going to go ahead and cross multiply this here first. So, the C times the sine of 43, the 22 times the sine of 97, so I have C times sine of 43 degrees equals 22 times sine of 97 degrees. I'm going to ask that you try and hold off on rounding until the very end. I know it's going to be kind of a pain, in the butt because you have all this other extra writing that you have to do, but it'll be a good practice for you because it's going to add to your precision. All right, so hold off on rounding to the very end. So we'll continue to solve for C here. It was C times sine of 43, so we'll divide both sides by sine of 43. Those will cancel. Now the C equals, and it's 22 sine of 97 over sine of 43, or if you wanted to at that point, I guess you could have just typed in your calculator. Okay, which is then approximately, so that's the precise answer, right? 22 sine 97 over sine of 43. That's exactly what the answer will be, but now we're going to have to round because we're going to get some crazy numbers. Crazy decimals, I'll say. Okay. So we type it all in, and again, let's just say 3 decimal places, okay, unless the directions specify otherwise. So 32.018. Okay, and again, that's a side measure, so we're not going to put a degree there. Okay, so approximately 32.018. Okay. All right. So we've got a missing side there. Any questions on that so far? Any questions on that so far? Pretty straightforward stuff. All right. So now what? We don't have side B, so we won't be able to figure out angle B using law of sines, and we don't have angle B, so we won't be able to figure out side B using law of sines. So what can we do here? We're kind of stuck. Law of sines won't be able to help us right now. What can we do though? Help us figure this out. Missing piece. Isn't it? So we could maybe use Pythagorean theorem here, but what must be true about our triangle if we're going to use Pythagorean theorem? It has to be what? A right triangle. Okay, we don't have a right triangle here. So you have Pythagorean theorem. I'm glad you brought that up. Pythagorean theorem, we have to throw that out now. Okay? It's not a right triangle, and so we can't use it. Okay? We cannot use it here. It's not a right triangle. So but good thinking. So what else though? What else? How else do we go about solving this? Again, we just want to find this angle B and this missing side right here. So what could we do? If we do any ideas about how to find either of those things? Yeah, Ellie.
Find angle B.
How?
Just subtract 97 and 43 from 180.
Yeah, exactly right. Okay, so any triangle in Euclidean geometry, all the angles have to add up to 180 degrees. So 97 and 43, take those from 180. Exactly right. Okay, so 40 degrees then, right? So don't forget that simple calculation that we know. All right, 40 degrees is what angle B has to be. And now that we have angle B, we can use that to find the opposite side, AC or side B, whatever you want to call it there, okay? Side AC there. So now we'll set up the ratio again. I would suggest that you go back to your given information here, the angle A and the side A. You could use C and side C, but if you made a mistake here, well, you're also going to make a mistake here. You're guaranteed to make a mistake. So go back to your given information. Okay, so sine of 43 again over 22 equals, and then the sine of 40 over little b, we'll say. Okay, if we cross multiply and solve for b, we're going to get the b equals, well, I guess we'll, yeah, b equals 22 sine of 40 over sine of 43. Okay. I kind of skipped some steps there solving, cross multiplying. Okay. But that's what you should end up with there. All right, and we'll just type into our calculator. Please make sure you close the parentheses right after you type in sine. All right, so close that parenthesis there, 22 sine of 40 divided by sine of 43. That one's not necessarily closing, but you know, it's a good habit. So about 20.735. Good morning, Mr. Goff.
So, identifying, labeling, evaluating.
Okay, so no adding
That's
subtraction.
more abstract.
Okay, gotcha. Is that what number is that in the section? Do you remember?
17.1.
Okay, gotcha.
I don't know.
But it is all in one section.
Yes.
Okay.
We're supplementing because, as always.
Okay. Are you gonna bring me some presents then?
Hopefully.
Okay.
I think Mill's on.
Okay. Thank you. All right. So then, there we go. Any questions on any of that? Okay. Law of sines. Okay. All good there. All right. Let's continue on. Let's try another one here then. Okay. Oh, let's do that one. Okay. Yes. Here we go. We got it going. All right. Let's try another one here then. Okay, so again, same thing. Sometimes directions will be simple as like solve the triangle, and that's all you'll be asked to do, just like solve the triangle. Okay, so that's what we're gonna have you do here. So we'll just say solve the triangle, which means just find all the sides and angles. Okay. Okay. So let me draw a picture here of this. And again, forgive me, I'm not drawing these. I'm trying to draw these to scale, but if they don't quite right, well, I apologize. If they look like they're right triangles, well, they won't be. Let's see here. 28. And 25. Okay, and again, I'll call A, B, C. All right. So, how should we go about starting this one? Where should we begin? How should we start here? Any ideas? Yeah, Bailey? Find the third angle. Exactly. In fact, that is the step we have to take. In the previous problem, right, maybe some of you, when you saw that we had two angles there, you went ahead and just solved for that third angle, and you know we're ready to go on from there, right? You saw that and you just did it. You knew it was there. But in fact, we didn't have to solve for that missing third angle. We had some work that we could have done, right? We did some work before being forced to solve for that third angle, right? And the reason why we were able to do that is because we started with a side and an opposite angle, or an angle and opposite side pair there. Here in this one, right, again, non-right triangle, so we can't use, Pythagorean theorem or any of those things, but in this one, we don't have a angle opposite side pair given to us at the start, but we can figure it out like Baylor said, and that's what we have to do, okay, is find this missing angle so that we have an opposite angle and side pair to start with. So 180 minus 32 minus 28 is 120 degrees. Ooh, this is, really not drawn to scale here, okay. But you get the idea. Just use your imaginations. Okay, 120 degrees. That little acute angle there is 120 degrees. All right. So now we can say, all right, sine of 120 over 25 equals, and then we can just take another side here. I'm going to solve for C. So we'll say sine of 32 over little c. And again, I'll put like a little c right there and a little b right there. So sine of 120, we can actually do that mentally. It's going to be root 3 over 2. Okay, root 3 over 2, that's one of our special right triangles. That's one of our, unit circle angles. It's 2 pi over 3. Sine of 2 pi over 2. But again, sine of 32 we can't do, so you'll have your calculator for this. All right. So anyway, we'll cross multiply here. So I get c times sine of 120 equals 25 sine of 32, and then divide both sides by sine of 120. Bless you. And so you get C is exactly that, the 25 sine 32 degrees over the sine of 120 degrees. Okay, so type into our calculator to get a side measure. I get like 15.297 about. Okay. So C is about 15.297. And so we have one more side to solve for here, so let's go ahead and do that. Alright. So let's see here. We'll say, and again, I would recommend you go back to A and side A, okay? So angle A, 120, and then the 25 feet there. Just because if you made a mistake in your other calculation, you're going to definitely get this other one wrong. So you want to make sure you set yourself up for success. So there's that. Again, we'll cross multiply and solve this one. I'll just jump the steps and And so we'll type that into our calculators. Sine 25 sine 28 divided by sine of 120. Okay, and that's approximately 13.552. Okay. So again, approximately. I guess you could really say those are feet too, right? I guess I should use. Okay, since we did have a unit there. Right? So that's law of sines. Okay. That's law of sines right there. I'm going to have you guys try one. Here. Okay, so not too shabby. Alright, so y'all try. Again, so I want you to solve the triangle. I guess solve the triangle ABC that has the given measures. Okay, so we're the directions are solve the triangle ABC that has the given measures, and we're going to say that the measure of angle C is 108 degrees. Side C, we'll say, is 56 meters, and side B is 27 meters. Okay. So go ahead and find the remaining pieces there. Bless you. Question? Okay, right there. I'm sorry. You like raising your hand for like minutes? Okay, good. What's up? Okay, right. How do you get them by itself? What cancels out sine? What do you use? So the opposite side. The second side. The decimal there. So like you want to do like an answer like that? Yep. Okay. Oops, that is not a degree measure. Actually, I don't have to make 180, but 180. Oh, you're making the exact measure. Oh, I see. Okay. You got this. That was the sine of b equal to that, right? So 27 sine of 108 divided by the sine, what is that, 26 there? So you get that. Okay, so that's not your angle. That's sine of b equals that. You want just b. Okay, how do you get b by itself? Arc sine. Take the arc sine of that decimal, and that'll then restore the angle. Okay. cosine of side A, you can use it. Because then you kind of handle this kind of stuff. You need to use something. So, in this case, you don't really need. Yeah, you have to use the approximation.
And then she goes through
Okay. All right, let's take a look here at our solutions. So if you didn't hear, I'd recommend drawing a picture. At least it helps me to organize my thoughts and stuff like that, right? Just being given these words here, not super helpful, although it is kind of obvious that we do have an angle and opposite side, right? So there's where we start, the 108 and the 56. All right. And then we solve for, I found B, angle B first. In fact, you have to find angle B here first because you know side B. Okay. So you know side B, we'll solve for the angle B there. You get about 27.293, which then allows you now to solve for angle A, 44.707, which then allows you to solve for side A, about 41.422 meters there. Okay, so one little twist here that I threw at you that we didn't talk about before, right, is that initial solving for angle B, right, when you set it up, we have sine of 108 over 56 equals sine of B over 27. Again, if you choose, you make it 56 over sine of 108 equals 27 over sine of B, up to you. When you isolate, when you get down here to sine of B equals this, when you do this math right here, you get about a decimal, like 0.458 or something like that. Right? But that's what sine of B is equal to about 0.458. We don't want to know what sine of B is, though. We want to know what angle B is. So that's where we do arc sine or sine inverse of both sides. You can use your calculator, to do that, obviously. So it's really going to be sine inverse of 27 times sine of 108 all over 56. And you get about 27.293 degrees there. Okay. And so there you go. So you had to use inverse trig to find that initial first angle. Okay, so questions on any of that? So one other thing I want to point out here, we're not going to hit it today, but I'm going to kind of just give you a little bit of a preview for tomorrow. All right, has to do with our information that we're given here. So, for example, when we started here, this first problem, right? I think we started with these two angles and then this side given. All right, so in triangle terms, right, back when you guys learned about from geometry, remember you did those triangle congruence proofs? Yeah, there we go. I thought I heard, yes, someone, their heart stopped a little bit right there. Yeah, no, we're not going to do proofs, all right, but if you remember, right, we had certain situations, certain scenarios, certain information that could guarantee that two triangles are congruent. So, for example, right, we had angle, angle, side, or side, angle, angle, depending on the order that you put it in here. And in this case, right, that's what we had. We had a side and then two angles, all right? The side was not between the two angles, so it was like, you know, next to them. So it's angle, angle, side. We were able to find and solve that missing triangle right there. So angle, angle, side. That guarantees a unique triangle right there, right? Here in this one, for this example, right, you can see the triangle congruence that we kind of utilized here was angle, side, angle, right? We took advantage of the fact that, okay, well, we have two angles on the side between them, which created and guaranteed, therefore, a unique triangle. For this one, our given information was angle, side, side. Right, the one triangle congruence that everyone wishes was an actual triangle congruence. Or not everyone, maybe, but you know, whatever, it's there, right? But it's not a triangle congruence, right? So angle, side, side is not a triangle congruence. We are still able to solve this, but in fact, there are sometimes situations where you are given an angle, a side, and a side of a triangle, and two possible triangles could exist from that information. And there's also some situations, because again, angle, side, side is not a congruence theorem for triangles, right? It doesn't guarantee the two triangles are the same, just knowing an angle on the side and a side. So here in this situation, we had one triangle that was possible. In some situations, there will be two triangles that are possible. And in some situations, no triangle is impossible. You'll be given like an impossible triangle, all right? And we'll look at that tomorrow. That's called the ambiguous case of the law of signs. Ambiguous because we don't know whether there's one triangle that exists, two triangles that exist, or no triangles that exist, as with all the information. So that only occurs when your starting information is angle, side, side, or as all geometry books write, side, side, angle. Okay. So anyway, we'll look at that tomorrow, though. We'll look at that tomorrow, so you don't have to worry about it for right now. But just as a heads up, all the ones, well, actually, the ones we did here were nice and, you know, easy to work out and stuff like that. Okay. So, what we're gonna do now, okay, I'm gonna stop right there, and we're actually not gonna have any homework from the book. What I